Here's my tutoring on the scientific notation quiz. So the state has this many people, the entire country is this. So how much greater is the population? By what factor? You notice it says times. So we're going to take the greater number and divide by the smaller number. So 3e8 over 5e7. 3/5 is 6/10. So this part becomes 0.6. This is 8 minus 7 is e1. This is not in scientific notation, so we will make this number bigger because the decimal goes here, digit dot. And if this is getting bigger, this must get smaller, which is that. Now, also, for all you math type people out there, what we now have is 6 times 10 to the 0, and anything to the 0 power is 1. So we have 6 times 1. And also I get two significant figures, I noticed. So that's a 0, that's a 0.0, and that's a 0.0. And then this then is 6.0 times 1, which of course is just 6.0. Write this in standard form. That would mean that the decimal is 3 spots smaller than what it appears here, which means you got to back up 1 spot and then 2 more, which means you have 2 zeros in front of it. Now the difference between meters and centimeters is a factor of 100, which is 2 decimal points, which means times 10 to the 2. So if you use a bigger ruler, you get a smaller answer. Imagine measuring the whole football field in yards. Well, from end zone to end zone, you get 100. Now measure it in pencils. If you use a smaller measuring device, your answer gets bigger. I'm going to have to turn this over many more times than 100 to get the whole distance end zone to end zone. So if we're going to use a smaller unit, we're going to go to one of these. The answer is going to get bigger. The two that are the most attractive are millimeters and centimeters. Now, centimeters is off of meters by a factor of 100. That's what centi means. So if you're going to use a smaller ruler, your number gets bigger by the same factor. So this is a smaller ruler by a factor of 100. My answer gets bigger by a factor of 100, which is times 10 to the 2. So my decimal didn't move from here to here, but my times 10 to the power, my exponent did. -1 is 2 times bigger, 2 decimal points bigger, 100 times bigger than 10 to the -3. So this is 100 times bigger than that. But when you then make this have E0, you get 0.31. If this is going to get down to disappearing, this has got to disappear because it's not in my answer. So let's double check. Don't just put this, double check. This has got to be E0 because it's gone in here. It's got to be 10 to the 0, which means times 1. 10 to the 0 is 1, so we would have times 1. But if this is going to get bigger, this has got to get smaller. This is getting bigger by 1 decimal point. This has got to get smaller by 1 decimal point, in which case we get this, which is not what they said. This is the true value of centimeters for that figure, but that's not what D says. It says 3.1. The true value would be 0.31. So this in millimeters is going to be 3.1. Watch this. Millimeters is off of meters by a factor of 1,000, which is 10 to the 3rd. So if you're going to use a smaller ruler by 10 to the 3rd, your figure will get bigger by 10 to the 3rd, which means you get 3.1. And this will grow by 10 to the 3rd, which gets you 10 to the 0, which means you can effectively cross this out like that. And we get 3.1 times 1 because 10 to the 0 is 1. That is the true value for millimeters, and that is in fact what B says. (800E9) is deliberately not put in standard form. So which of these is true? If this has got to go, the decimal here has got to go back 2 spots, that's getting smaller. So this has got to get bigger by 2 spots. So we get 8.0 times 10 to the 11. This has got to get bigger by 2 decimal spots. So what's the exponent on k to turn this into that? The decimal used to be here, it went back 6 spots. So this decimal is actually 6 spots bigger than I'm currently showing you, because it's out here, right? So k is 6. The exponent should be 6 to turn this into that. So the combined mass of the paper clips is going to be this times that. So we have 5e3 times 6e minus 3. 5 times 6 is 30. When we take the exponents on 10, we add them. So we get 3 positive minus 3. So that is E0. Remember, 10 to the 0 is 1, which means we just have 30. To be really picky, we should put in that this is clips, and this is kilograms per clip, which then cancels out the clips and gives you kilograms as the unit on your answer. So we can multiply the first part, and that's 64, and then we add the exponents, so we get minus 6 and plus 11 is times 10 to the 5. However, the decimal point belongs back here, so we get 6.4. Now this got smaller. This must get bigger, E6. Oh yes, I also get 3 significant figures. I don't get 3 significant figures. It is, that is my point. And now that I remember, I deliberately did that. We only get 2 significant figures because this data point is in 2 significant figures. And take a note, kids, when you're multiplying or dividing, your answer gets as many significant figures as the number of significant figures in your smallest data point. This has 3 sig figs, this has 2, therefore in your answer, you're only allowed 2. So there is a difference between this, and the answer is that, because that has 2 significant figures, so my answer only gets 2 and not 3. I almost did it wrong myself. So what's the sum of these? Now this does get a little tricky. What you're going to need to do is line up the decimals, but for realsies, and it's tricky with the scientific notation in it. And again, no calculators, not for this one quiz. So note to self, it's easier if you take the smaller number and make the exponents match the bigger number. So let's take this one and change it and keep that one. So I'm going to keep that one. And I'm going to change this one, and I need it to be E-4. And this just got bigger by 1 decimal point. This part then needs to get smaller by 1 decimal point. So I get 0.415. And then we can add them up. And if you add chairs and chairs, you get chairs. If you add grapes and grapes, you get grapes. So we get E-4 kind of falls through as any common multiplier would there. And we get 5963. However, we don't know what was in the third decimal here. It's unknown. So I don't know plus 5 is not really 5, it's I don't know. So we're going to have to round this off, and we get 3.6. Actually, this rounds up, doesn't it? 3.70. And we do know the second decimal in both cases, don't we? So we do get to go to the second decimal. Don't just stop with the first one, because it seems like, well, I don't know, well, I'll just chop it down to be more accurate or something. No, we do know the second decimal. We're pretty confident that's much more of a 0 than a 1, or than it is 6.9 or something. So we do know the second decimal, so it's this one. So we could rewrite this as 6.0 E6 over 2 E-2. 6 over 2 is 3. We get 2 significant figures in our answer because that has 2. I know that has 3, but this has 2. And in multiplying and dividing, we get as the least number of significant figures in our data. So since one of my data points has 2 sig figs, I only get 2 in my answer. And then we subtract the exponents on the bottom. So we get 6 minus a minus 2 is 6 plus 2, so we get E8, which is why it's this one and not that one, because this is E positive 8, which is true, and this one has 2 sig figs. Which one's in correct scientific notation? This one is supposed to be a pretty easy one. We go digit dot, it goes digit, not 0, not a 0, that does not count. And then a decimal point, so this is the only one that obeys that convention. This one is to test just mental math. Most adults will tell you that if you divide by a half, then you get half. No, you don't, and I will prove it to you. Here are my square pizzas, because I feel like making a square. How many halves can you shove into one? How many halves do you get? You get 2, don't you? If you divide it into halves, one pizza turns into 2 pieces. If you divide this giant piece into a halves, you get another 2. So if you take 2 and divide it by half, you get 4. Dividing by half is the same thing as multiplying by 2. And if you're having trouble with that one, hit pause and think about it and ask a neighbor or ask me. Dividing by a half is multiplying by 2, and I would write that down and I would memorize it, because I expect a lot of technical mathy type majors out of this class, and that is going to come up, I guarantee it. So I get 8.00 E4 divided by a half. 8 divided by a half is not 4, it is 16. And then we subtract the bottom, but that's E0 effectively, so we get E4. This decimal is not in the right place, so I then push it there, so I get digit dot. This got smaller, this must get bigger. The area will be the dimensions multiplied by each other. So we have 8.0 E5 times 2.0 E4. 8 times 2 is 16. We add the exponents and we get 9. However, the decimal is not in the right place. It needs to go here. So this is 1.6. This just got smaller. This must get bigger, E10. Oh yes, and it's meters times meters. So whoops, meters and meters. So this is meters squared. So it is 1.6 times 10 meters. There we go, square meters. I think I pointed at the wrong one before. There we go. It is not meters, and following those units is going to be important if you're in anything technical. I mean, even just contracting, which can get very technical. If you're going to build houses, you got to know your units. When we add, we need to make the E numbers match. It's easier if you take the smaller one and make it into the bigger one. So let's take E5 and change it. Let's keep this one because it's bigger. 5.000 E negative 4. And then I want to make this one turn into E negative 4. This is getting bigger by 1 decimal point. It's getting bigger by 1 decimal point. This must get smaller by 1 decimal point. Double check though. Do I know the third decimal in all cases now? Yes, I do. So I get to keep the third decimal. I don't need to throw it out. There's no reason to throw that out. This is the correct version. This is just asking you what's 10 to the 0. It's 1. Anything to the 0 power is 1. You can look it up anywhere you want. I promise I'm right. So this is just 6.78. What's this in standard form? It means back the decimal out by 4 places, go smaller. So 1, and then you're going to need 3 more, so that's 3 more zeros before you stick the decimal in, down. So that's 3 more zeros after you go back after the 6. 1 and 3 more. Whoops, typo there. What is this in scientific notation? The decimal needs to go back here. so that we get 6.4, and that decimal here, written here, let's be very clear, means that you do mean the zeros. If you're going to put the decimal when it doesn't help the number as such, it means I'm serious about these zeros. I measured them, and as far as I can tell, those are actually zeros. I'm not just putting something in there to push the decimal around. So we're going to keep all 4 significant figures, which tells you, well, it tells you it's that one, doesn't it? Also, though, this decimal got moved 3 back, so we do times 10 to the third. This decimal is not here. It is 3 spots bigger. You know what? I forgot my zeros. There we go, 0, 0. I said we were keeping them, and then I didn't have them. This decimal is not here. It's 3 spots bigger than what I am showing you, and the unit is kilometers. Again, line up the decimals, but you have to make the E numbers match, the exponents on 10 match. It's easier if you take the small one and make it into the big one. So let's keep that one. And let's change this one. If this is going to get bigger by a factor of 10, then this must get smaller by a factor of 10. This comes down. We're going to borrow, make that a 10. That's a 5. This is a 4, remember, so that's a 3. We do not know the third decimal in either case. We do not know the third decimal, plus that's wrong. Here you go. But if this is in scientific notation, you're going to go back 1, 2, 3, 4, 5. So it's 2.0. And where's the decimal? It's 5 spots farther back than what I'm showing you here. Farther back, smaller than what I'm showing you. I just discovered that I was wrong in 19, and I'm wrong. And we had to skip it, and I'm wrong. It does not illustrate the thing that I meant, and I think I had a slight misconception myself. How about this one? 8.0 over 2.00 is 4. We get 2 significant figures, so 4.0, and then meters squared over seconds over meters per second does this. One of these cancels one of those, and one of those cancels one of those, and you just get meters. 4.0 meters. Meters then.